Welcome back, scholars. Have you ever wondered why, when you throw a stone, it curves so beautifully before landing? That elegant path is called a parabola, and it's governed by a secret partnership between two independent forces. To understand this, we must break down the motion into two distinct worlds, the horizontal and the vertical. These two dimensions coexist in the same space, yet they completely ignore one another's actions. Let's examine the horizontal component first. Imagine launching a projectile in a vacuum with no air resistance. According to my first law of motion, an object in motion stays in motion at a constant velocity unless acted upon. Because there is no horizontal force pushing or pulling the ball, its forward speed never changes. It covers the exact same horizontal distance every second, marching forward at a perfectly steady, unyielding pace. But the vertical dimension is a completely different story because of a persistent force we call gravity. As soon as the object leaves your hand, gravity begins to pull it straight down, accelerating it continuously. Unlike the constant horizontal speed, the vertical downward speed increases by nearly 10 meters per second, every single second. It is a state of constant acceleration, mimicking a simple object dropped straight down from rest. Now, what happens when we combine these two? This brings us to a truly legendary and counterintuitive puzzle. Imagine we have two bullets. One is fired perfectly horizontally from a high cliff, and the other is simply dropped. They start at the exact same height, at the exact same microsecond. Which one hits the ground first? Most people would guess that the fired bullet, traveling at incredible speed, stays in the air much longer. But the truth is far more astonishing. Both bullets will strike the flat ground at the exact same moment. Why? Because their vertical falls are driven solely by gravity, which acts identically on both masses. The horizontal velocity of the fired bullet cannot delay or speed up its downward vertical descent. They are falling at the exact same rate. Gravity doesn't care how fast you are moving horizontally, it pulls you down regardless. When you combine this constant forward motion with accelerating downward motion, you get that graceful curved path. Each point on that curve represents the perfect mathematical intersection of steady horizontal travel and accelerated vertical drop. In the real world, air resistance or drag will slightly warp this perfect parabola, slowing both components down. But the core principle remains: perpendicular motions are completely independent of each other. This fundamental concept is what allows us to calculate everything from satellite orbits to the perfect basketball shot. Subscribe to James Physics 101 for more micro lessons and keep mastering the motion of our incredible universe.